Welcome back, guys. We are starting one of the important areas of financial management, and that is investment appraisal. It's one of the core areas of financial management. It is the area where you might see questions in all three sections of the exam, be it MCQs, MTQs, or constructed response questions. So historically, its weightage has always been very significant in the exam. So no student can afford to have weaknesses in this area. So we'll be starting from a very basic of investment appraisal. And from very basic to advanced, we'll be discussing all the areas of investment appraisal one by one. So let us start with a very basic concept, compound interest. So we'll just understand with the help of figures. So let's say we have a project that asks for $10,000 of investment. And we are being told that we will be getting 10% interest per year. Let us denote it by R, rate of interest, and the amount of investment required, we will call it principal for the time being, $10,000. And the life of the project is, say, 2 years, to keep it simple. And we need to find out what will be the sum after 2 years. So if we invest this amount for 1 year, the amount of interest will be 10% of 10,000, which will be 1,000. So in a 1 year's time, the sum will be 1,000 plus 10,000. And that's $11,000. So the total value of the investment after 1 year will be $11,000. In the second year, the amount of interest will again be 10%. But since it's a compound interest, the rate of interest will not be applied to the initial investment. It will be rather applied to the sum at the end of the first year, which includes the interest earned. So the amount of interest will be 10% of the total compounded amount, which is $11,000, $1,100. So for the second year, the interest will be $1,100. And the total sum after 2 years, n is equal to 2, will be 11,000 plus the second year's interest, which is 12,100. So in 2 years, we've got 12,000, we will be getting $12,100. And this is called your sum. Now, how do we calculate this? With the help of a formula. Let's derive a formula which will allow us to calculate this amount directly with the help of formula rather than going through these many steps, because the investment might be of 5 years or it might be of 10 years. So we cannot solve it on a year by year basis. We should know the exact value that we are going to get after 10 years or after the end of the project. So how we can do that? Let's derive a formula. Firstly, if you just look at this, what have we done? Our principal is 10,000, and we know that after first year we will be getting 10% of interest. So our amount will be 10,000 plus its 10%. So 10,000 into 1.1. If we multiply it by 1.1, it will give us this figure of 11,000 directly, as this factor will allow us to add 10% to the basic amount, 11,000. And if the same is multiplied by 1.1 again, it will give us this 12,100 figure. Here we go. So if we multiply the principal by 1 plus r, that is 1.1, twice, we will get the figure after 2 years. And instead of multiplying it by 1.1 twice, we can just take its power as 2. It will give us the same answer. Instead of multiplying it by 1.1 twice, we can have a power of 1.1 and then multiply it with the principal value. It's the same. And if we analyze this formula, we can just see what variables we have used in this formula. B2 is your principal, so we can have it replaced by the principal P, denoted by P, right? Because in every question the figure won't be 10,000, so let's define it by a variable P. Then its multiplication sign, 1.1 because the rate of interest is 10%, which means 0.1. So we have added 1 and r together to get 1.1 figure. So if it was 20%, I would have multiplied it by 1.2. So 1 plus the rate r, and then the power, which is 2 in this case, but obviously every question will have its own time period, so we'll denote it by n. And if we do it, it will give us s. So s is equal to p into 1 plus r raised to the power n. This is the formula for compound interest, and with the help of this formula we can find some principal, rate, or even the number of years. So let us put the values directly and see if we can get this answer. So P, which is 10,000, into 1 plus the rate, 10%, raised to the power 2, 12,100. So from now onwards, whenever you have to do compounding and you need to find out a future value of an amount, this is going to be the formula, and this formula is a formula for compounding. So what is compounding? Compounding is basically when you know P and you want to find S. So from P to S, the process is called compounding. That is adding the interest every year to find out a future value. And the same formula could be reversed to find out P with the help of S. Say for example, if we know that the sum is 12,100, that is the amount that we are going to get after 2 years is 12,100. And we have to reverse this figure to find the P. We can use the same formula, but with some changes. Let's do some changes. Now let's change this formula for P. So as you know that this whole factor is being multiplied on this side, and if something is multiplied on one side, it will be divided by the other side. So if we keep it as P, then we have to divide S by the factor which was earlier multiplied by P. So it will be 1 plus R raised to the power n. So this formula can be used to find out P. So if we will be actually going from 12,100 to 10,000, that means we will be subtracting the amount of interest. In the earlier case, we were adding the amount of interest when we were calculating the future value. But when we are calculating the principal going back to the initial value, we are actually subtracting the amount of interest, and this process is called discounting. So when you are finding P with the help of S, so you are actually going from S to P. From S to P is discounting. You know the S, that is the future value, and you need to find out the today's value, the investment value, that is P. But the same formula could be written as P is equal to S, and the denominator could be taken to the numerator of the same side, but in that case we have to change the power sign, that is from plus n to minus n. So these both formulas are same, they will give you the same result, the same values, it's just the different arrangement. So both of the formulas could be used for calculating P. So let us try this. So now we need to find out P. So we know the S value, 12,100 into 1 plus the rate of interest, that is 10%, power minus 2. So the resulting answer should be 10,000, and here we go, we have got 10,000. So this is how we do compounding, and if we know the value of today, that is the amount of investment of today, and we need to find out the value after 3 years, 4 years, or 5 years by adding the interest, this is how we do it. So let's say we have a question here. Let me remove the answers from here. So we have a question here. A company is expecting to invest in a 2 years project, at the end of which it will receive a total of 112,636. If the company wants to earn a return of exactly 6%, what should be the amount of investment? That is, you need to find out P. So just pause the video and find out the amount of P in this question. I hope you've calculated it, and it's a very simple thing, right? So what's the sum? The sum is 11236. 11236. Rate of interest is 6%. N is 2 years. That is, this amount will be received in 2 years' time. So what will be the amount of investment today if we want to earn a return of 6%? So S into 1 plus 6% raised to the power minus 2, 10,000. So if you invest 10,000 today in this project and you add 6% every year, the amount will be 11,236 after 2 years. Another example is a company is expecting to invest in a 2 years project, at the end of which it will receive a total of 11,236. Same figure. If the company wants to earn a return of exactly 6% per year, how much will it save or lose if required investment is $9,000? Now understand this question. If the company wants to earn a 6% return, it should invest 10,000, right? It should invest 10,000. That's what we have calculated. So by investing 10,000, it will exactly earn a return of 6% if it receives 11,236 in 2 years' time. But what the next part of the question says is that, let's say the required investment is $9,000, not 10,000. The required investment is 9,000, and they will still be giving us 11,236 in 2 years' time. Now, in case if the company is needing a return of 6% and required investment is 9,000, how much it will save? So just look at this. 11,236. If it wants a return of 6%, it has to invest 10,000, right? But instead of 10,000, the required investment is 9,000. So it means for an investment where we are ready to invest 10,000, the asked investment, the required investment is just 9,000. So obviously, let's say it's just an example. If let's say you think that a car is worth $10,000, you can buy it for $10,000, but the seller is just asking for $9,000 for the same car. So it means you are buying a car at $9,000, whereas its worth is $10,000. So you will actually be saving $1,000. So the gain in this case is $1,000. I hope this is clear. Now just pause the video. I'm just asking another question. Pause the video, think about the answer of the question, and unpause to see the answer. Let's say if you have the same question, exactly the same, but the required investment is $10,800. Instead of 9,000, the required investment is $10,800. Just think for a while and come up with the answer how much the company is going to save or lose if it goes for this investment, providing that it needs a return of 6%. Okay, same question, and I've just changed this figure. Now the required investment isn't 9,000, I'm just revising it, and it's 10,800. So we want to invest 10,000 because the required return is 6%. But for the same investment, they're asking for 10,800, which is 800 more than what we should be investing. So if we go for this investment, we'll straight away lose $800 because the worth of investment is $10,000, whereas the required value is 10,800, which is 800 more than what we want to invest. So we'll be losing $800. That's the loss. Let's move towards a few more questions. Now this loss of $800, or earlier it was 1,000 gain, what is it called? So just look at it. This P is also called present value. This is also called present value. And this is basically a value which tells us how much maximum we should be investing to get our required return. As you all know that after 2 years we were told we will be getting 11,236, right? And with the help of this figure, we just calculated how much we should be investing today for this cash flow that we are going to receive in 2 years' time if we need 6% return. So we found that if we invest 10,000 today and we add 6% annually to this amount will be increasing to 11,236. Let's check it as well. Let's say we invested 10,000 today, and in 1 year's time we got 1 plus 6%, right? We will get 10,600 after 1 year, and if we add further 6% to this, what will be the answer? It is going to be 11,236, exactly what we are getting. So it is proved that if we invest 10,000 and we add 6% to this amount, this will be exactly what we are going to receive from this project. So it goes without saying now that if a company wants to have a return of 6%, it must not invest more than $10,000. And this figure is called present value. So we can say that present value is basically the maximum that a company should invest if it requires a certain return. And 11,236 was cash inflow. This is the cash inflow because the company will get this amount in 2 years' time. So it's a cash inflow. And since we have calculated present value of this amount, so we can call it present value of cash inflow. So the $10,000 that we calculated is called present value of cash inflow. That is the maximum we should be investing in this project. Then this amount is compared with the required investment. This is the investment required today. The company has to make this investment today. So we can call it present value of cash outflow because this is an outflow for the business. The business has to invest this amount, and since it has to invest today, we can say it's a present value of cash outflow. And this 1,000, which we call gain, is basically the difference between these two present values. The present value of cash inflow and present value of cash outflow. Since this is net of two present values, we call it net present value. This loss or gain is basically called net present value as it is a difference between two present values. Net present value, net of two present values. It's called net present value. And A positive net present value results when your present value of cash inflow, which is the investment that you want to go for, is more than the required investment. That is, when present value of cash inflow is greater than the present value of cash inflow. And if it is greater, it suggests us to invest in the project. And if it is less, it will suggest us not to invest in a project. So whenever NPV is positive, it means the value of investment is higher, whereas the required value of investment is less. So we should be going for it. Similarly, like if you think a car is worth $12,000, but the seller is just asking for $10,000. So you will have a positive value of 2,000. That positive value suggests you should be going for the investment. So remember from now onwards that a positive NPV means we should be investing in the project, and a negative NPV means we will be rejecting the project. So we have 2 questions more on your screens. Just solve these 2 examples and switch to next video to find out